Good day, good night, good morning, good evening, whatever time it is wherever you are. Welcome to yet another video where we delve into specific topics on the CSEC mathematics syllabus. This video will deal specifically with the topic of standard form or scientific notation. So without any further ado, let us get straight into the mechanics of the transition from the decimal form to standard form. The decimal form is the form that we normally use in our everyday usage. Alright? 5 is decimal, 125 is decimal, 12.36 is decimal, 0.85 is decimal, 0.0097 is decimal, etc., etc., etc. These are the decimal numbers that we are accustomed using, but we're going to move now from decimal into standard form. So, what are the rules of the transition from decimal form into standard form? Alright, so look at this carefully now. Any decimal number d could be written as t multiplied by 10 to the power of p. Alright, I use the letter d here to signify that we're moving from decimal numbers, decimal form. I use this t here to signify that this particular number is a number between 1 and 10. So the t there would serve as a reminder of the 10, which is that the number is a number between 1 and 10. Now the number doesn't have to be the number doesn't have to be an integer. It could be 1.6, it could be 3.85, it could be 6.79, etc., etc. Alright? So this t here doesn't have to be an integer. This p, however, which is the power of 10, must be an integer. Right? It could be a positive integer, it could be a negative integer, it could also be 0. So it could be 1 or it could be minus 1. It could be 2 or it could be minus 2. It could be 3, minus 3, 4, minus 4, etc., etc., etc. Alright? So this here is the basic template to switch from decimal into standard form. As a side note, this number t here, the official term for it is the significand. Right? And you will see the significance of that not too long from now. Alright? So this may not necessarily be something you have to be aware of for the purposes of your CSEC maths exam, but it is good knowledge to have. Just by the way, significant. Right? So your decimal would be a significand by 10 to some power of p. Alright, so your significand must be between 1 and 10. So, let us now go straight into some examples where we shift from decimal form into standard form. So, I'm going to use two similar numbers of different orders of magnitude. The reason why I'm going to do this is to demonstrate the difference between the positive power and the negative power of 10. Alright? So the very first step, and take note of this, the very first step in transitioning from decimal into standard form is to place the decimal point immediately after the first significant figure. Alright? I'm going to repeat that. You place your decimal point immediately after your first significant figure. Right now, in the previous video that I did where we spoke about significant figures and decimal places, right, we went into great detail explaining how to find the first significant figure. So I'm not going to go through that again in this video. I will just get straight into it. With that knowledge assumed, if that knowledge you don't have it, then you have access to the video. Go and check it out. Alright? So, in both of these numbers, the first significant figure is here, 2. Right? 2 is the first significant figure here. 2 is also the first significant figure here. So, placing the decimal point immediately after the first significant figure will land us at 2.946 here, and the same 2.946 here. Alright? So in both of these cases, your t, using my notation, or a significand using the official notation, the official definition, is 2.946. Now these two numbers are different, so the final outcome in significant in standard form cannot be the same, obviously. So what is the difference? Alright, with that takes us to the next step now. The next step is to count the number of movements that it took to get your decimal point behind the first significant figure. Let me repeat that. Step 2. Count the number of movements that it took to get a decimal point from where it was in the decimal form to a position immediately behind the first significant figure. So, in both cases now, we had here, we had to move 1 place, 2 places, 3 places, right? So we could say immediately that this is 2.946 by 10, and we could put a 3 here immediately. Similarly here, alright, we had to move, in this one, sorry, right, so in this one the point was here. So we move now 1, 2, 3 to get it here. Alright? So in this one we could also put 2.946 by 10, and we could put a 3 here. And I am doing the example like this deliberately with the same t or significand and the same power p, the only difference being that one would be positive and one would be negative. Alright? So that we now have to figure out which one to put as positive and which one to put as negative. Listen to this and listen to it very well. Alright? Anytime a decimal number starts with 0, 0.3, 0.35, 0.96, 0.00047, 0.0894, etc., etc. Any number decimal, any decimal number that starts with 0 point something, your power in standard form must be negative. Must, by definition. Alright? In other words, you're starting off with a fraction, a number between 0 and 1. So, using that guide, then we know that in this number, the power would be minus 3. Alright? So what we actually have here would be 2.946 by 10 to the power of minus 3 as the final outcome. Over here, we have 2.946 by 10 to the power of 3. And if we want to double check, right, we could come in the corner here and say 2.946 by 10 to the power of positive 3 means that we're moving the point to the right. 1, 2, 3, end up with 2.946. Similarly here, if we start with 2.946 by 10 to the power of minus 3, we go 1, 2, 3, we end up with 0.00029446. Alright? So, just to reiterate, alright, your first step is to determine your t. And you do that by placing the decimal point immediately after the first significant figure. Your second step is to count the number of movements of the decimal point that was necessary to get it behind the first significant figure. That will give you the value of p, the magnitude of p, right? And then the sign of p would be determined by the actual number you started with. So if you started with 0 point something, then the sign of p will be negative. And if you started with 1 point something or 36 or some other number that is greater than 1, then the sign of p would be positive. So I'm going to do one more example just like this, just to drive home the point, and then leave you with some questions to do as practice. Alright, so we have another pair of numbers here. On the top we have 0.04389. Below we have 43.89. Alright, so just by looking at these two numbers, we know immediately, without lifting a pen, that the power of 10 here will be negative in the standard form, and the power of 10 here will be positive. That is what I wanted to get to. From the time you see the number, you know immediately that this is something by 10 to the power of some negative number, and this is something by 10 to the power of some positive number. Alright? Good. So with that in the background of your mind, we could go through the mechanics step by step. So the first step again is to place a decimal point immediately after the first significant figure. Alright? So in this case it would be, we move the decimal point one place, two place. So we end up with 4.389. Same thing here. In this case, we move decimal point one place. Here we get 4.389. Alright? So this would be 4.389 by 10 to the 1, because we had to move the decimal point one place to get it behind the 4. And here it would be 4.389 by 10 to the power of 1, 2 minus 2. Alright? So, yeah, 1, 2. Good? And that is as straightforward as it is. Alright? There is absolutely no reason at all why you should be losing marks if you have to change something from decimal form into standard form. But like everything else, it requires practice until the process becomes automatic. And when the process becomes automatic, you will get to the point where in one line you could see this as, okay, 0.04389. You know that it will be 4.389 here, multiplied by 10 to the 1, 2, 1, 2. 10 to the minus 2, obviously. And then you get to this one here, 43.89 to start with. You move the point one place, 4.389 by 10 to the power of 1. The process really gets automatic the more you're practicing. Alright? And it is my intention at some point to do a little document on this. Right? But even in the absence of such a document, you all have this video and the accompanying exercises as practice. Alright? So just to recap, alright, the first thing you do is find a t or a significand by placing the decimal point behind the first significant figure. The second step is to count the number of movements that it took to get the decimal point from the original position in the decimal number to its new position behind the first significant figure. Alright? The number of such movements would determine the magnitude of the power of 10, which is a p in my notation. Alright? And then to determine the sign of the power of 10, if your number was 0 point something, then the sign would be negative. If your number was greater than 1, then your sign would obviously be positive. And that is basically it. One quick trick question before we close up this video. Alright, watch this. If I ask you to express, let us say, 2.35 in standard form, or 7 in standard form, what would be your answer? 1 second, 2 seconds, 3 seconds. The quick answer is that these numbers are already written in standard form. Alright? Because in both instances, the point is already behind the first significant figure. Right? So you already have a t in place. A t, of course, being that number between 1 and 10, where your point is after the first significant figure. Right? The first significant figure here being 2, of course, and the first significant figure here being 7. So these numbers are in decimal form, so if we had to rewrite them in standard form, it would simply be, in this case, it would be 2.35 by 10 to the 0, sorry. In this case, it would be 7 by 10 to the 0. Why 0? Because we didn't have to move the decimal point at all. Right? Being as it was behind the first significant figure from the start, so no movement was necessary. So the power of p is 0. And this 10 to the 0 we know from the subject of indices. 10 to the 0 is equal to 1. So this will be 2.35 by 1 or 7 by 1. Alright? So if per chance you get something like that in a multiple choice especially, or maybe even in a paper 2 or paper 3, who knows? Don't be scared. Don't think that this is some kind of trick question. You may get the number already in the T form. The number being already between 1 and 10. In that case, you just add multiplied by 10 to the 0, and this here would be the official standard form. Alright? So, as always with the video, you have the option to rewind and listen again if you need to drill the point home, if you need to repeat it. You have the questions to practice with answers provided, and of course you have the thread accompanying the video where you can make your comments, and you may even opt to contact me directly if you so choose. Alright, so let's get this done. One more notch under the belt, forward march.